This is a revision video for C1, cracking and combustion of fuels. Many fuels we use come from crude oil. Crude oil is found underground and we need to drill to obtain it. We obtain the fuels that we use through fractional distillation of crude oil. But its use has many problems associated with it, one of which is oil spills. Oil spills can cause a lot of damage to the environment. So, for example, the destruction of beaches and habitats of animals. Animals can really suffer from oil spills. Birds in particular, when their feathers get covered in oil, it sticks them together so they're unable to fly properly. The pollution from oil spills at sea can also find its way into rivers. It takes a lot of effort to clean up after an oil spill. It takes days and days to clean up a beach, and some beaches take years to clear. The fuels that we obtain from crude oil through fractional distillation are mostly short chain length alkanes. However, crude oil is packed with lots of long chain molecules. Now, these are not very useful to us because they are not very good fuels. The molecules are really long, and therefore there are a lot of intermolecular forces between them, which take a lot of energy to break. So therefore, they are not very good fuels. However, we can crack them into shorter, more useful chains, like petrol. This is done using heat and a catalyst. This process turns a long chain alkane into a shorter chain alkane and an alkene with a double bond. In industry, this process is done on a massive scale, but we can do it on a smaller scale in the lab. What you would have to do is soak some mineral wool in your liquid fuel, so in this case paraffin. You would have your catalyst within the boiling tube and then a flame to heat it up. You then have a delivery tube which will collect the vapour and it goes into an iced water bath. The purpose of this is to condense the vapour back into a liquid. Also, if there are any shorter chains, even shorter chains, they will continue to be a gas and they will be collected in this tube over here. Fuels are really useful to us because they're a way of releasing energy that we use for a number of different situations. When fuels burn, they react with oxygen in the air. If there's plenty of air and therefore plenty of oxygen, we get complete combustion. Now, this is the general equation for complete combustion. You have your hydrocarbon plus oxygen gives you water and carbon dioxide. So it might be methane, it might be ethane, it might be propane, it might be heptane. Any of those hydrocarbons, if they completely combust with oxygen, give water and carbon dioxide and lots of energy release that we then use for lots of different purposes. However, there is a problem with combustion. In some situations, we get incomplete combustion. This is when there is not enough oxygen present. So there is a little bit, but not enough. The hydrocarbon reacts with the oxygen and it produces carbon monoxide, which is CO, and carbon, which is C, and then water, which is H2O. Now, the carbon, not so much of a problem, as it would just give you some black powder, like the thing that you get on your burnt toast. That's carbon. However, the other product that is really dangerous is carbon monoxide. Carbon monoxide is a poisonous gas. It is very dangerous, it doesn't have a smell, and you can breathe it in without knowing it. And what happens is, the place in your blood cells where the oxygen attaches to the hemoglobin, the carbon monoxide is just the right shape and size to fit in that gap. So what it does is it binds itself there and it stops the oxygen from binding there. Therefore, your blood can't carry oxygen around your body as effectively. And what happens is you would just fall asleep and never wake up. So it's very, very, very dangerous. You can treat carbon monoxide poisoning if you catch it early enough. And what we would have to do is put the patient in a very, very high pressure oxygen chamber so that the pressure forces the carbon monoxide back out of the blood. If you are really worried about this, you can also buy carbon monoxide detectors to go in your home, and they usually will have a coloured patch on them which will change colour in the presence of carbon monoxide. Now, lots of exam questions about fuels will ask you to analyse some data and then make the best choice. Now, imagine that there's a new power plant going to be built near you, and there are 3 options: coal, fuel oil and natural gas. This could be an example of what you got in an exam, so a table with lots of information about each one, and then you would have to compare the fuels to justify a fuel that would be the best to use. So we're looking at how easy it is to get to, how expensive it is, how much energy it releases, does it contribute to acid rain or the greenhouse effect, how easy is it to use, how poisonous is it, how easy is it to store. Now obviously there is not one that stands out in every different category. So we've got one here that's got medium energy value that has got a very low cost. However, its pollution is very high and it's difficult to use. We've got one over here that has got a high energy value, a high cost, medium pollution and very easy to use. Very low poisonous gases produces, but difficult to store. So what you would have to do in an exam question is state some advantages and disadvantages of each one and then weigh up which one would be the overall best to use. So sometimes there's not even a right answer to this as long as you can justify your choice. So remember, you need to make comments about advantages and disadvantages of each one, and then you need to sum up which one you think is the best. Remember to always say why. So always give examples of why you have chosen the fuel. These are really good questions because the answers are all there inside the table. You just need to be able to pick them out.